In this video, what we're going to take a look at is different ways on how to visualize data or how to display data in different ways. And the reason why this is important is, well, typically when we're talking about data, we just have a big list or perhaps a table of numbers or other bits of information. Looking at this big table of numbers, looking at all this information, very rarely is this useful. Very rarely is it easy to tell what's happening from this list. Data visualization, this way to display that data in a useful way, is then extremely important for us to be able to quickly overview the data, quickly overview what is happening, and get an idea as to the distribution, the most frequent, or where our data is even located. An example of this, and this is going to be kind of using our qualitative data, so this is data that's measuring the quality or the attribute of an item. Let's suppose that you're sitting there in class. Imagine we're back in the classroom and you're bored, surprise, it's statistics, and you're looking out the window and you're looking at all the cars out there in the parking lot. And you're looking at them and you're going, I wonder which color car is the most popular, right? This is how bored you are. Even this question seems more interesting than the statistics we're covering. So you're there and you're looking in the parking lot and you start writing down red, red, blue, yellow, gray, red, blue, as you see the cars out there. In the end, you're just left with a list. You're left with a list of all these different colors. What do you do with this list? If you wanted to show someone, hey, what is the most popular car? Sure, you could just say, hey, look, red showed up the most. I think I said red the most. And there we go, you're happy. But maybe there's better ways to display this. Maybe there's better ways to show this. And that's one of the big things that we're going to look at today. A little bit of a follow-up question. This is going to be something that you should be able to answer from the previous video. If you were there recording the color of all these different cars, what level of measurement would that have been? Again, if you're lost on that, go back. What were our 4 levels of measurement? And see if you can work out what that level of measurement would have been. We'll get to that. We'll talk about it again as we get into this video, but hopefully you could answer that now. Carrying on then, for today, what we're going to be looking at, again, this whole idea of data visualization. Here are the big objectives as to what we're going to achieve by the end of today's session. So first, we're going to start off with qualitative data. We're going to take a look at ways how to display qualitative data with a bar chart as well as a pie chart. To be honest, we're not going to be using pie charts too often. I rarely find them useful. Bar chart is going to be the big one that we utilize the most. We'll then move forward onto quantitative data, and we'll take a look at 3 ways to display that. We'll take a look at a stem and leaf, a histogram, and an ogive. Between those 3, the histogram is again the one that we're going to focus on the most. So just to give you an idea as to where we're going, let's jump forward and take a look at qualitative data and different ways to display it. So jumping back to our parking lot situation, let's suppose that we are looking out the window and we have in front of us our parking lot full of cars. And let's just make that picture of the parking lot a little bit smaller so that we have some room to work with it. There we go. Okay, so we have our parking lot and we have our cars. And we're looking at this and we want to find a way to display and to show this information in a way that's easily transferred to others. So keep in mind, when we're talking about color, color is a qualitative source of data. That is, no one color is better, no other color is worse. We're just simply describing an attribute. Similarly, to answer that question we asked before, color is a nominal level of measurement, right? So to keep in mind our levels of measurement, nominal, ordinal, interval, ratio. Nominal is the lowest. There's no sense of order in here. It's just strictly attributes. So in order to display this data, one of the first things we're going to want to do is we're going to want to create a frequency table. That is, we're going to want to organize all of our different observations in such a way that is easier to realize. So to start off, let's build this frequency table. So for this frequency table, what we're going to want to know is, we'll just build it right underneath here. We'll want to know the color. So color and the frequency. So how often that color occurred. We'll then just draw a vertical line to split the two in half so that we can create a bit of a table going on here. Next step, we go back just to our raw data and we start to just group it together. So one that pops out to me is white. So let's just take a look. Seems like there's a lot of white cars here. Let's count them all and go from there. Good way in this case here is let's just cross them off as we count them. So I have 1, 2, 3, 4, 5, and 6. So first color there, white. I have 6 cars. Carrying on, what do we have next? Let's go with blue. 1, that's kind of blue. 2, maybe that's purple, we'll give it blue. 3, 4, and I'm going to say that's black. So we'll go 4 blue cars. We carry on in much the same way. We could go on next and take a look at our red cars. Red cars, I'd go with 1, 2, 3. Let's say yellow. What do we have? We have 1 and 2. And finally, what's left? Just this one guy that I'm saying, maybe that's a black car. In retrospect, that guy in the corner is probably black as well, but we'll leave it as it is. So we have all of our different colors sorted by frequency now. Actually, that was just by chance that I sorted it from most frequent to less frequent. There is, again, being nominal, being an attribute, there is no sense as to which order we should put this in. Although it is quite common to put it in some sort of order, such as either alphabetical by attribute or frequency, smallest to largest or largest to smallest. Moment of truth, what we should be doing here is we should go and we should sum all of our frequencies to figure out what exactly that works out to. And in this case here, what do we have? 6 and 4 is 10, 13, 15, 16. That there is the summation of all of our frequencies, and that should be the same as the amount of cars we have up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Perfect, we didn't miss any. That's what we're checking there, is to see, did we miss anything or did we double count anything? From here, from this frequency table, we can now move over into creating our bar chart. And a bar chart is just another way to visually represent this table. So let's take a look at that. So for our bar chart, we have 2 axes. We're going to have our vertical axis, which is the frequency, and we're going to have the horizontal axis, which is all of our different attributes, so the colors. Always make sure you label your axes, otherwise no one knows what exactly you're measuring in each case. And so we have frequency there, and we have color on the horizontal. Next bit, well, let's give this a rough scale. So 6, let's go a little bit beyond 6 so that we're not right up against the top. I'm going to go and we'll say that's something like that. I'll say that's 8. Again, I'm not looking for a perfect scale. We're just kind of trying to get the idea doing this by hand. And so 8, I'll cut this in half. I'll say that's 4. Cutting in half again, 6, 2, and then we have 1, 3, 5, and 7. So rough scale doesn't look too bad. Maybe I'm a bit big on the bottom, but we get the idea. Along the bottom here, well, we're going to put our attributes. In this case, well, I kind of like that we've done the frequency from most frequent to least frequent, so I'm just going to keep it in this order here. If you wanted to, you could go least frequent to most frequent, or you could do it alphabetical. So with our axes set, next thing we want to do is get in our colors. So going from left to right on the bottom, I'm just going to go here. Let's do white. Another tick, trying to keep about the same distance between each one. Next guy here, I'm going to be going blue. Next one, same idea, red. Do I have enough room for all of these? Yellow. And final one, doing my best to maintain. Again, this is the thing with freehanding this, is it's best you can. And last one here we're going to be doing is the black. Okay, so we have our axes set up. What we want to do is we now want to put in the bars for the bar charts. So in this case here, our bar is going to be centered at our qualitative variable. So in this case here, our qualitative observation is white, and we observed it 6 times. So we're going to create a bar coming up from white towards 6, and then back down. If you have the capability, you can do something fancy, like we could shade this in white. But all this extra bit is just gravy, just making it easier for the viewer to actually understand what's happening. I mean, honestly, if we have colors, we could do each of these bars a different color too, based off of the observation. This is one of those little things, though, you really need to be careful about. If you are going to play around with colors, do your best to make the colors actually match the color of your title. Nothing is worse than looking at a bar chart and finding white, and then they use red for the blue one, and they use yellow for the red one, and all their colors are mismatched versus the title. So always make sure you're watching out for that. Either keep it one color or make sure the colors match the qualitative variable. Next one there, blue. I'm just going to keep all mine white just for simplicity. And we had 4 observations for blue, so let's bring that up. Right about there, that's 4. And back down. Red is 3, so 3 goes up to about there. And back down. Yellow, what do we have for yellow? Yellow, we had 2. Boom. And finally, black had 1. Okay, so we have our bar chart. Few things to notice with this. I'll talk as I just shade these guys in a little bit. Freehanding it, you might notice that a few of these bars are a little bit wider than others. Now, ideally, you'd want them all to be the same width. That's just, again, an artifact of us freehanding this diagram. So ideally, they should all be the same width. That is, width doesn't actually represent anything in this context. The other thing to notice is that our bars do not touch each other. There is this visible gap between each bar. That is because dealing with qualitative variables, that is color being qualitative, white does not flow into blue, which does not flow into red. There's no logical reason why we should have gone white, blue, red, yellow. We could have easily gone black, yellow, red. We could have easily gone alphabetical. Although typically it's visually appealing to do highest to lowest frequency, or alternatively do lowest to highest. That's our typical adoption for displaying qualitative data. But other than that, there's no logical connection between white to blue. These variables do not flow into each other, thus the gap between the bars. One other final thing to note with our bar chart here is our vertical axes. One of the big things that you never want to do is cut your vertical axes. You never want to cut it, and what I mean by that is say we had hundreds in this case. So this was something like 101, 102, 103, 104, 106. It would be really tempting to change your axes and actually let's do this a bit of a different way. To change your axes and just go, let me just use different colors to show that we're overwriting this. You never want to use one of these. So this here little ziggly line in the axes means that there's a break. And to start it then at 102, 104, 106, 108. The reason why you don't want to do it this way is it gives a perception that there's a huge difference between the number of white cars and the number of black cars, right? It's just like, wow, there's a lot more white than black. But in reality, 106 really isn't that much more than 101. Or alternatively, right, if we go back, if we just undo what we just added there, alternatively, 6, well, 6 is a lot more than 1, right? That's a 600% increase from 1. So that's a massive difference between these two. But 106 is not that much more than 101. And so you can very easily create a misleading graph by cutting your vertical axes. So that's a big no-go there. Next, what we can also do is we can take a look at the relative frequency. So instead of the absolute frequency or the actual frequencies we have here, like, hey, we had 6 white cars, we could take a look at the relative frequency, and we could choose to display this in terms of relative frequencies instead of actual frequencies. To obtain this relative frequency, all we're going to do is take the actual frequency and divide by our number of observations. So that would be 6 over 16, and so our relative frequency would be 0.375. I don't have room to show that, so let's just go like that and update that to be 0.375. Carry on, 4 out of 16, well, that's going to be 0.25. 3 out of 16 is 0.1875. 2 out of 16, 0.125. And our final one there, 1 out of 16, 0.0625. And in this way here, all of these relative frequencies, if we have done our math right, 6 divided by 16, 4 divided by 16, 3 divided by 16, all of these relative frequencies should sum to 1. If you were doing some rounding, you might have some rounding error in there. It might sum to 1.001. It might sum to 0.9999. That's fine, right? Doing it by hand, you're going to have an element of rounding. But if we're doing this on a computer where it carries forward all the decimals, this will sum to 1. So we could do it in that way there. Very similarly, we could just update this axis. Instead of being the actual frequency, we could update it to be the relative frequency and put in the corresponding values as such. Chart would look the same. The only difference would be the values here because they'd be the relative frequencies rather than the actual frequencies. So maybe we'd start it at 0.4, 0.35, 0.3, 0.25, 0.2, right? And go down by that 0.05 all the way down. Could do it in that manner. So that's our bar charts, actual frequencies, relative frequencies, and how we create a frequency table and then go from the frequency table to the bar chart. If you have any questions about that, feel free to shoot me an email, ask during office hours, post to the D2L-FAQ. Next, we're going to go and take a look at what we can do to get this over to a pie chart.